All right, so as you can see, I am not here today, so I'm going to do these video notes for you. Then you are going to go to Schoology and complete, there's a little assignment in there, like, Schoology questions for you to do. You may work together. You can, use your notes and whatnot. It's just like a little classwork. You have 2 attempts to get your best score. And so you do that, and then you are going to complete a worksheet that the substitute has for you on composition, and then you are done. If you don't finish the worksheet, you can take it home, but I would like you to finish them. I think you have time to finish them both in class. So let's get going. And then your homework is just your test corrections to have those all done. Right, so last class we did a lot of function operations, and one of them kind of went like this, like when somebody gave you a function and they said, hey, find f of 2. That does not mean multiply, that means to plug 2 in place of the x, right? So f of 2 is 3 x squared, so 2 squared minus 5 times 2 plus 2. All right, so then we know we do PEMDAS. 2 squared is 4, so this is 3 times 4 minus 10 plus 2. That's 12 minus 10 is 2. 2 plus 2 is 4. Okay. All right. So we're going to be doing the same thing, but instead of plugging a number into a function, we're going to be plugging another function into a function. So it's a little bit weird. So this is how you say this. This is said f of g of x, right? So f, think of the parentheses, f of g of x. The parentheses is kind of like the word of. So this means to plug g into f. Plug g into f. Just like I plugged 2 into f, all right? It can also be the other way around. So usually you're given 2 functions and then you have to do one or the other. This means g of f of x. And the names can be different, but this means to plug f into g. Now this little circle right here, that's the that's the notation for composition. All right, that's what this is called, composition of functions. Okay, all right, so let's get started down here. I have h of x and p of x. So this tells me to do p of h of x. So it tells me to take h and plug it into p. So here we go, p of h of x equals. So P is the boss. He's the boss of everything, and you're going to plug h into him. So I'm going to write down this p phrase, 2 blank space minus 3. So in that blank space is where I actually put the other problem. So I'll get another color here. So the other problem, this is where I put h of x, right? So h of x is 5 minus 3x. So then I just go and simplify the problem. 2 times 5 is 10, 2 times negative 3 is negative 6x, and then minus 3. So this reduces right, negative 6x first, and 10 minus 3 is 7. So then I just work it out. Okay, so my answer is a whole nother problem. All right, so h, it doesn't say hop. Remember, this means h of p of x. So I should have written it lower, but I'll just go with it. So h is the boss. H is outside here. So 5 minus, and then 3 blank space. Well, in that blank space is where I put p. It's 2x minus 3. Okay. All right, so let's work it out. 5 stays. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is plus 9. So I'm going to write the negative 6x first, and 5 plus 9 is 14. So your answer is another problem. Okay, so this is the weirdest one. I'm going to do this over to the side here. P of x. So you're plugging p into itself. So I'm going to write p down, 2 blank space minus 3. So in that blank space, I write 2x minus 3, which is what p is. So it's a little strange, but that's just what it says. So 4x minus 6 minus 3. So 4x minus 9. All right, and the last one. So you notice the last one has a number. So what this means, if I write it the regular way, it's always better to write it like this. So this means p of h of negative 3. So p is the boss, yes, but what I've given you right here is I've given you something that you're able to find the answer to. So find it. What's h of negative 3? So I'm going to put negative 3 in here. So h of negative 3 is 5 minus 3 times negative 3, right? Plugging negative 3 into it. So that's 5 plus 9, so that's 14. So now I know that this whole part is just 14. So what you're really being asked to do is P of 14. So you're taking the answer from one problem and plugging it into the other. So that means I'm going to plug 14 in here. So 2 times 14 minus 3. So 28 minus 3 is 25. Okay. All right, so we're just going to practice this a little bit more with some harder problems, but really not that much harder. Okay, so f and g this time. Here's f of x squared plus 4, and g of x is x minus 6. So who's the boss? F is the boss, right? So f of g of x is, I write down f with blank spaces. Blank space squared plus 4. So in the blank space, I put g, x minus 6. So now this one's a little bit annoying, all right? X minus 6 squared, I gotta write it twice and work it out. Don't you dare just do x squared and 6 squared. That's not what the answer is. X times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x again. And negative 6 times negative 6 is positive 36, and then plus 4. So my answer is x squared minus 12x plus 40. Okay, here's this one like earlier. So really this means g of f of negative 3. So g is the boss, but I have given you something that you can actually figure out. So let's figure it out. F of negative 3 is negative 3 put in here. So negative 3 squared plus 4. So that's 9 plus 4, that's 13. So I'm going to plug 13 into g. So 13 minus 6 is, what, 7. So when you plug in a number, you get a number for an answer. When you plug in another problem, you get another problem for an answer. All right, g of f of x. So g of f of x. So g is the boss. So here's g, something minus 6. So something minus 6. So in the something spot, I put f, which is this expression, x squared plus 4. So the parentheses aren't really doing me much good. They just drop. And then minus 6. So all I can really do is write x squared minus 2. Done. Okie doke. So down here, so you can always also do this using a picture. So remember from before, I have two pictures on here, f of x and g of x, right? And so I'm asking you for different things. We did this on our warm-up the other day. So f of negative 4. So I go to negative 4 because that's the x value, right? So I go to negative 4, and look, up here is where f is. So the answer is 3. That's the point, 3. So what this tells you is that there's the point negative 4, 3 on the picture, g of 6. So I go over here to 6, there's g, it's at negative 2. So what this tells you, it tells you that there's a coordinate, 6, negative 2, on the graph, okay? So f of g of 3. So, look, let's find this, g of 3. So this is a composition like earlier. So g is down here, g of 3 is negative 3. So this is f of negative 3. Well, f of negative 3, here's negative 3, there's f is at 2. So the answer is 2. And you can't really do a point for this one because it's using two different problems. All right, so let's figure out f of negative 7. So here's f, negative 7 is 6. G of that 6 is, looks like negative 2. Okay, all right, so the last little bit, you're going to start learning about something called piecewise functions. So up until now, you've mainly dealt with functions that are continuous. So there's no breaks or like gaps in the problem like you see here. There's no, I mean, this is continuous, but that's a little bit weird, that sharp turn. But anyway, in other words, there are no breaks or gaps in the domain or the graph. But sometimes functions are defined only for certain x values, and sometimes you can have many different pieces of a function put together to make one like overall picture, right? To create what's called a piecewise function. So like, look, there's two pieces here. On this problem down here, there's 3 pieces, like a line, a parabola, and a line, okay? All right, so we're just gonna practice the beginnings of this here. So f of 5, I do the same thing I did before. I go over to 5, find the answer is at 9. f of -1, go to -1, oh look, there's the graph, it's at 5. f of 4, go to 4, the graph is up there at 8. Now this one's kind of special here, f of 2. So 2 seems like it's two different places, but the answer is this part that's filled in, the black part. So f of 2 is 6, not the 0. All right, so let's also try to write the equation for this. So you can write the equation for this, it's just broken into two parts. So what you do is you write f of x equals, and then you make a little bracket. It's going to have two lines. The equation of this line up here, this is the line y equals 5. Now this one's a little bit more tricky. I can see the slope of this line is 1, so y equals, like, I'll just put 1x. I have to continue this line down, and when I continue it down, I see it was going to cross at 4, so I'm going to put plus 4. So that's his equation, x plus 4. All right, so I'm going to name those two things. So I'm going to say that the graph, you're supposed to graph the line y equals 5. Remember, f of x is y, so f of x equals 5, comma, so for when I am using numbers behind 2, so less than 2. So everything less than 2, I'm supposed to, like, here's 2, here's my breaking point. Everything before 2, I'm using this line. So I say only use those when x is less than 2. And then I'm supposed to use this line right here, which is x plus 4, so y equals x plus 4 when I am everything to the right of 2. So 2 and to the right of 2. So for x's greater than or equal to 2. So this is like the problem, and these are the rules of when you're supposed to use them. So you use this answer when you do a number less than 2. You use this problem when you do a number bigger than 2. So look, 5. If I want to use 5, 5 is bigger than 2. So I plug it in here. 5 plus 4 is 9. Oh, let's try -1. -1 is in this category, so I'm using this answer right there. So it kind of tells you the directions. Okay. All right. So this next one, and we'll do more of this and stuff like that later. All right. So this guy, notice that g of x seems to be made up of 3 different functions. 1, 2, 3. 2 lines and 1 parabola. Remember those U-shaped graphs, parabola? So we're not going to come up with the equations for this because that's a little bit too hard for us now. But let's do some points. G of 5. So 5 is using this line here. The answer is also 5. 1. So 1 is the parabola in the middle. The answer happens to be 1. -1, it's right at that corner, but it's at 1. And 2, so g of 2, right here, I'm supposed to use the black dot. So 4, this is empty. So it finishes here and jumps up and starts over. Okay, so you don't need a picture to do these things. You also can be given an equation. So this is my equation. There's 3 different things. There's an equation for before or equal to 2. There's an equation for between 2 and 5, and there's one for 5 and after. So you just have to decide which number, what category this number falls in. So 4. 4 is in the category between 2 and 5. So I'm supposed to plug 4 into this problem. So I'm supposed to do 4 squared plus 1. Well, that's 17. 0. 0 is in this category. It's less than 2. So I'm supposed to plug 0 into this problem. 2 times 0 minus 4. So that would be -4. All right, 6. 6 is in this category. 6 is bigger than 5. So I'm supposed to plug 6 into this problem. So that would be 6 plus 6. 12. And then 2. 2 is in this category. See, it's not equal. It's equal to 2, so it's up here. So I'm supposed to plug 2 into there. So 2 times 2 minus 4. So 4 minus 4 is 0. Okay, so that gets you used to piecewise functions a little bit, and we'll be doing a little bit more of those. All right, be good, do your work, do a good job. Bye-bye.